Hello and welcome to another session about geometry. Today we'll be talking about Pythagorean theorem and its converse. Okay, so here's the Pythagorean theorem. Okay, given any right triangle, if you take the square of this side, in other words, you square this number, and then you add it with the square of this number, you should have a number that results in the square of this number. Okay, so I'm not going to go over any major proofs with this. There's a really cool proof that if you take the area of this, like if you use this length and then find the area, or like make a square out of it and then find that area, and then you take this length and make a square out of it and find that area, if you add up those two areas, they will add up to this third area of a square that you would make with this side length of C. So that's kind of where the idea comes from. It's kind of cool how it works, and plus you would make a triangle in the middle. It's an amazing theorem that just works. Now, does this work only for side lengths? Yes, and you do need certain stipulations to actually work this. You need at least, well, you need two sides. Okay, if you had all three sides, you wouldn't need to use this formula a whole bunch. You could use A and C, you could use A and B, you could use C and B, and then find the other third missing sides. Totally up to you how you want to do it. Okay, now here is a list of Pythagorean triples. Now, if you notice, the first set in each list, like 3, 4, 5, 5, 12, 13, and 9, 48, 41, these are the first set, and there's a ton. There's actually an infinite amount of Pythagorean triples. Okay, but if you notice, if you kind of like, if you multiply them by 2, okay, you get this second set, and if you multiply it by 3, you get this third set. And guess what? All of these are Pythagorean triples. Okay, these are just the originals. These are like the scaled down versions. So 3, 4, 5, 5, 12, 13. If you multiply them by 2, you get the same thing as what we got up there. If you multiply them by 3, right there. And then the same thing for 9, 41, and 40, or 40 and 41. Okay, so Pythagorean theorem and its converse, you guys have seen it quite a bit. Now, also, its converse is that Pythagorean theorem says if we fulfill this, then we have a right triangle. Well, the converse is if we have a right triangle, then we can fulfill this statement. So that's what we're working with right here. So let's go practice it. Okay, so are these numbers, that should say these, my bad. Let me change that real fast. Oops. Okay, are these numbers a Pythagorean set? So 1, 2, and 3. So the first thing we do is we just square it. Now, how do we know which side is the hypotenuse? Okay, the hypotenuse is always going to be the biggest side. Okay, as a matter of fact, this 2. Yeah, there will actually be 2 of these. Okay, and then right here. Okay, alright, so we're going to check it. 1, 2, and 3. So we're going to square 1 plus 2 squared equals 3 squared. Okay, alright, and obviously that is going to turn into 1 plus 4 equals 9, which is not true. Okay, simple as that. Now this one right here, we're going to do 2 squared plus 2 squared is equal to the square root of 2 squared. Okay, and when you set that up, that should be 4 plus 4. And when you square square root, it just turns into the number. So this one is also nope. Okay, very simple stuff. Now this one right here, 5 squared plus 7 squared equals the square of the square root of 80 squared. Okay, so 5 squared is going to be 25 plus 49. And once again, when you square a square root, it just becomes the number because the square root and the square cancel out. And once again, nope, not a possibility. Okay, so are these numbers Pythagorean set? No, and there's like an infinite amount of list of them, okay, that just work with this. Okay, so if we knew that this was a right triangle, we knew this side was 7 and this side was 12, we would need to be able to find the third missing side. So what I'm going to do is I'm going to set it up. You can write out the formula the first couple of times you actually do it. So a squared plus b squared equals c squared. Okay, so you can start plugging in numbers. So I could say that that would be, and it doesn't matter where a and b go. It doesn't matter what order. Okay. Let's go x squared. I'm sorry, I was just looking at the problem up there. I think I screwed up the number 2 problem, so I'll go back and talk about that one. Okay, so 7 squared plus x squared equals 12 squared. Okay, and so that turns into 49 plus x squared equals 144. Okay, now we're going to minus 49 from both sides, and we're going to get x squared equals, I believe that's 95. Hold on. 44 minus 49. Yep, that is 95. Okay. All right, now to finish this off, we can't say that x is going to be 95 because that would violate the triangle inequality rule. So what we're going to do is we're going to square root both sides. So we go ahead and square root both sides. Okay, and you try to simplify as much as you can, and x should equal. Now normally, if this wasn't geometry, I would be saying, oh, if you're square rooting, you better get a plus or minus, but since we're in geometry, it's always going to be positive. When you're in algebra or some other math class, it could be positive or negative. It just depends on the geometry of the situation. Okay, and let me see, that would be the, and you simplify it the best you can. That would be 5 times 19. Okay, which we cannot simplify, so that just turns into the square root of 95. Okay? Alright, and that's your actual number. Now that's the exact answer. I don't want any of these rounding with decimals, please. Just try to get the best exact answer possible, okay? Alright, now to address the problem, I pointed out that the longest side is always going to be the hypotenuse. Well, this is one of the shorter sides. So this problem shouldn't have been set up that way. Now, if 2 sides are going to be the hypotenuse, that's an issue. So right off the bat, this should be ringing bells in your head that we have 2 sides that are longest. Well, hypotenuse, hands down, is always the longest side. The y of that, okay, is the hypotenuse is opposite the biggest angle. Okay, so if this is equal to this, then that means there is another right angle in here, and that's 180 degrees, leaving this to be 0. Well, if you notice, that's an impossibility. Okay, so that means that this problem should have never been done in the first place. That should have really rang off some bells. So let's start working with some stuff. Oh, here's one. 2, 2, 2, root 2. There we go. Okay, now this one is definitely going to be the longest side, so that's 1 hypotenuse. Okay, so that's 2 squared plus 2 squared is equal to 2 root 2 squared. Okay, so this turns into a 4 plus 4 equals. Now I'm going to, on this one, I am going to square the 2, which turns into this 4, and then I square the square root of 2, which turns into times by 2, so that just turns into times by 2. And if you notice, 8 equals 8, and therefore, yes, this is a Pythagorean triple. Okay, and we'll talk more about that special one later, but I wanted to show you some examples of ones that weren't totally wrong and devised by your teacher, but actually you figured out some stuff with it, okay? Alright, and that's it for Pythagorean theorem and its converse. I'll talk to you later. Bye.